We were writing simple ionic formulas in the last video, and we were looking at the periodic table to find the charge on the ions. However, at the time we said to skip the transition metals. They don't really follow a good trend in charge. Their valence electrons can change. So now in this video, we'll deal with the transition metals. They're very, very common. This is where you find your iron, copper, zinc. I mean, we're going to use these compounds all the time in the lab. But we have to treat them a little special. With the transition metals, you'll see a Roman numeral. And the Roman numeral will tell you the charge. So for example, you could see something like copper, Roman numeral 1, ion. That means that copper's charge is +1. The Roman numeral tells you the charge. But now what's tricky with these transition metals is that they can have multiple charges. That's why they're called transition metals. If the number of valence electrons can change, the charge can change. So you could also have copper, Roman numeral 2, ion. And this would be copper +2. So, I mean, the nice thing is that you don't have to look up the charge on a periodic table. The Roman numeral tells you the charge. The tricky thing is that we just have to be aware that a lot of these transition metals can have different charges. I mean, some of them can have like 4 or 5 charges. Manganese can even be like +6 and +7. They can have some kind of funky charges. But we don't have to worry about it. We'll know the charge by looking at the transition metals Roman numeral. So for example, here are some good formulas. We would read this as copper 1 sulfide. So that Roman numeral tells me that copper's charge is +1. And then sulfide is sulfur. I just look up the trend on the periodic table. -2. Now nothing is different. We still have to make this add up to 0. Copper +1 means copper is going to lose 1 electron. But sulfide -2 means that sulfur wants 2 electrons. How about we just have 2 atoms of copper? If we multiplied the charge times 2, then we need 2 copper in our formula. So, I mean, it's really no more difficult than writing formulas with normal metals, alkali metals, alkaline earth metals. I think maybe these are almost even easier. You don't have to look up the charge, it's just the Roman numeral. So for example, here we would read this as tin 4 chloride. This is the Roman numeral 4. Everybody always forgets 4 and 6. They remember this one, the V is 5. If you have the 1 in front, that means subtract 1. This is 4. If the 1 is in back, then you add. That's 6. And again, sometimes you could have these transition metals with Roman numerals of 6 or 7. So tin's charge is +4. Chloride is a halogen -1. I still need this to be neutral. The tin is going to lose 4 electrons. Chlorine can take 1. How about we just have 4 chlorine atoms? Each chlorine can take 1 electron from tin. So this is Sn for tin. Chlorine, we need 4. And again, you don't have to memorize the elements and their symbols. So if you're not sure, just look up tin. Like, oh, I think it's something kind of crazy. Oh yeah, Sn. Sometimes when they have these goofy symbols, it comes from like old Latin roots. Tin is Sn. Its Latin name is stannous. Weird. Okay, look it up. Now, one of the boo-boos that people will make is that we read this as tin 4 chloride. So then they write tin 4 chloride. Oopsies. Nope. Sad face. The Roman numeral is not the subscript. It's the charge. So when we read tin 4 chloride, we mean that tin's charge is +4. And finally, how about some nickel 2 phosphide? So nickel's charge is +2. Phosphide, phosphorus, is in the group that's -3. So we want to make this neutral, and again, you'll get kind of used to this. When you have a +2 -3 or a +3 -2, the common multiple is 6. So let's take 3 nickel and 2 phosphorus. Then we have 6 electrons donated from the nickel, and we can take 6 electrons with 2 phosphorus. These multipliers then are my subscripts. Nickel, I need 3. Phosphorus, I need 2. There are never negative ions that can have multiple charges. So you only have to worry about these transition metals that have a Roman numeral to tell you the charge. Piece of cake. Now, when you're writing the names, sometimes this can be a little more work. Because often people will say, when do you need the Roman numeral? I get this is like lead bromide, lead oxide. How do I know if I need the Roman numeral when I'm writing the name? Use Roman numerals when more than one charge is possible. Here are your choices. Transition metals, and there's 2 other screwballs, tin and lead. You wouldn't think tin and lead. They're down at the bottom of the carbon family, so you would think that they'd either be like +or -4. But they can actually go +2 or +4. And so you'll usually see a Roman numeral with tin and lead. They can have multiple positive charges. You'll always see a Roman numeral for transition metals. So the most common question, when do I need that Roman numeral? For transition metals, tin and lead. So for example, lead bromide, lead oxide, yep, we're going to need it. I know this is lead bromide and lead oxide. But since they can have different charges, if somebody just told me, hey, go in the lab and get some lead oxide, there are 2 different bottles of lead oxide, and their properties are very different. I wouldn't know which one to get unless I knew the Roman numeral, or the charge. So we're going to put in parentheses, and we got to figure out what charge is on that lead. Now again, the bromine is always -1. There are no negative ions that have multiple charges. So we're going to find the negative charge first, and then we'll balance it with the right positive charge to make it neutral. So bromine is -4, or -1. There are 4 bromine for a total charge of -4. Since there's only 1 atom of lead, and again it has to be neutral, the lead must be +4. So we'd say lead, Roman numeral 4 bromide. So we got to do the math. Again, it's not like rocket science. We'll find the negative charge first, and then we'll pick the positive charge that would make it add to 0. Oxygen is always -2 with no exceptions. There are 2 atoms of oxygen, which gives me a total of -4. Ah, interesting. So again, since there's only one lead, it must be lead 4. Lead plus 4. Sometimes people will get this one wrong because they'll say, well, there was a 4 in the first formula, there's a 2 behind the oxygen in the second formula, so maybe this is lead 2. Yeah, not necessarily. You really have to balance the positive with the negative. There are 2 atoms of oxygen, but each oxygen is -2. So you have a total of -4 in both. They were both lead 4. Again, check out these iron oxides. We have 2 bottles of iron oxide. Fe2O3 is rust. So that's like your orangey red powder. FeO is like a black powder. They're both forms of iron oxide. So again, you can't just tell me go to the lab and use some iron oxide. There are 2 bottles of iron oxide and they have very different properties. So we need the Roman numeral to show the version of iron that's used in these compounds. Iron is a transition metal, so I know I need a Roman numeral. These are both iron something oxide. Iron something oxide. Excellent. So we're going to work backwards. Oxygen is always -2. In this formula, there are 3 oxygen for a total charge of -6 on the back end. So we need to get a +6 from our iron. Now this time there are 2 atoms of iron. We want a total of +6. So what if each iron were +3? +3 times 2, that would give me a +6 to balance my -6. This then is iron 3. Iron Roman numeral 3. We want the individual charge on each iron, so we don't say iron 6. That is the total positive charge, but each iron must be +3. Ah, okay, this isn't so bad. If that made sense, the last one's really easy. Oxygen is -2. This time there's only 1 iron and 1 oxygen. So the iron must just be a +2. We'd say iron 2 oxide. Oh, not bad. Find the total negative charge first, and then we'll pick the version of the positive ion that we need to make it neutral. The most common question though is when to use the Roman numeral. When do I need it? Transition metals, tin, and lead. So again, there's lots of practice problems on the next page in the study guide, and it's the only way that you get good at this. You just have to practice. Try some of these. Bring the video back. You can pause it. Then bring it back to check the answer key. If you're getting them right, you're in a good place. If you're having trouble, again, come in for help ASAP so that this doesn't go on any further. It is a skill that must be mastered. All right. So hopefully you had a chance to try some of these ionic compounds with transition metals. And again, throughout the end of this video here, you can pause at any time if you want to check your answers, make sure you're getting them right. Or if you did half of them and you just want to record the answers and try the rest of them later, that'd be an excellent little practice test or quiz. Writing the formulas is usually not the problem. Some of these have transition metals and some of them don't. Sodium, potassium, calcium. they only have one possible charge. You can find it on the periodic table. But then silver, manganese, zinc, chromium can have multiple charges. And that's where you'll see the Roman numeral to indicate the charge that is used in that particular compound. Then you just make them neutral like any other compound. The issues usually arise writing the name, where people just don't know when to use the Roman numeral and when do I not need it. Magnesium, sodium, boron, barium, they all come on groups of the periodic table that always have the same charge. You don't need a Roman numeral. You only need the Roman numeral when there are multiple positive charges. Your choices are transition metals, tin, and lead. So manganese, chromium, copper, vanadium, yes, that's when I need the Roman numeral. To find the version of lead, or whatever the transition metal might be, we just do like in number 9. Find the total negative charge first, and then we'll pick the form of lead, or whatever it might be, that we need to make this compound neutral. So again, if you need to pause this, go right ahead. If you're ready, here's the bottom half. Check these over, take as much time as you need. You can pause this. And again, if there's anything in here that is causing you concern, or you find that you're not getting the correct answers, that's a red flag to come in and get help as soon as possible.